Hello and welcome to the first episode of Fun Derivation. And in this video, I'm gonna teach you how to derive pi. Not teach you, I'll show you a way in which you can derive pi. So in this video, we'll talk about the Archimedes derivation of pi. That is the idea Archimedes used to derive pi. So first take a circle and divide it into equal triangles. Congruent triangles. So all of these will be isosceles triangles and all of these will be congruent. So what does that mean? The third side of all those angles will be equal, and the angle subtended by the arcs. So in this case, we are going to take the angle subtended by the arc AB will be equal to theta, and all these angles, all this angle will be equal to theta since they all are congruent. So first we'll go off by finding the length of AB, and we know from the law of cosines that AB, or the third side, is equal to the root of the first side square, and this in this case, since it is a isosceles triangle, it's an isosceles triangle, we're gonna take we have to take the first and the second side as r, so we'll take r squared plus r squared, that is the radius, minus 2 times r squared, because that's 2 times AB, and instead of AB we write r, so r times r is r squared, 2 times r squared times the cosine of theta. Okay, so that just gives us AB equals 2r squared minus 2r squared times the cosine of theta. Now we will take 2r squared, since it is common in both the sides. We will take 2r squared out of this equation, this expression, and we're gonna get 2r squared 1 minus bracket 1 minus cosine of theta. So since both of these terms are getting multiplied to each other, we can take out the r, and we could write that AB equals, since it is r squared, and if we take it outside the radical sign, we'll get it as r times the root of 2 times 1 minus cosine of theta. So we got till this equation. Now if we were to multiply this side by the number of triangles, okay, we would get the circumference, we would get an approximate of the circumference. Okay, so let the number of triangles, let the number of this sides, this sides, so how many sides are there in this scenario? We'll take it as 1 2 3, there are 10. So in this case n equals to 10, but when we take n as 10, we don't get a better approximate of the value of pi, so we'll take the number of sides as n equals to the number of sides, or number of triangles equals n. And if we wanted a better approximation of this circumference, we will multiply. If we wanted the circumference, so the circumference will be nothing but the length of this the length of AB times the number of triangle, and in this case this is the length of AB, and we're gonna multiply it with the number of triangles. So we multiply and we get it n times the root of 2 1 minus cosine of theta. Now you have to substitute this theta with something, right? So this is r and not 6, and when we take theta and all these triangles are congruent, so we can write theta as the number of as 360, because all of this sums to 360, and we know the number of triangles is n, so we can write theta equals to 360 divided by n. So this angle will be same as theta, this angle will be the same as theta, that is 360 upon n, and all the angles will sum up to 360. So we could replace this theta, with 360 upon n, and we would get it as n times r root of 2 minus, sorry, not minus, multiplied by 1 minus cosine of 360 divided by n. Alright, so if we take the circumference, we also get this as 2 pi r. Okay, so what do we want here? We want the value of pi. So if we wanted the value of pi, we would divide this term by 2r. So we would take this 2r and divide this term by 2r. So we divide it by 2r, and I'll just cancel this out, and we'll get the value of pi on this side, the right hand side. So this r cancels out with this r, and we would get n upon 2 multiplied by the root of 2 multiplied by the 1 minus cosine of 360 upon n. Okay, so that will be equal to the value of pi. So you might notice that 1 minus cosine of any angle will be the same thing as 2 times the sine square of theta upon 2. Okay, so we will replace this cosine of 360 upon n with that value. Okay, so we will replace n upon 2, and we will replace the 1 minus cosine with 2 times sine square of theta minus 2. So what's theta in this case? So it is 360 divided by n, and theta upon 2 means this thing divided by 2. So we'll put 2 in the denominator, and this cancels out, and we get sine of 180 over n. So if we multiply this the 2 that we have outside of the bracket, if we multiply this 2 with 2 sine square 180 upon n, we get the same thing as, first we'll write pi equals n upon 2 multiplied by 4 times sine square 180 upon n, 180 degrees upon n, sine square of 180 degrees upon n. So we know that the square root of 4 is 2, square root of sine square is sine, and sine square 180 upon n is sine of 180 upon n. So we would get pi equals to n upon 2, that will be multiplied by 2, the square root of 4 is 2, and the sine square of 180 upon n will be 2 sine 180 degrees upon n. So we so as you can see, this 2 cancels out with this 2, and we simply get pi equals n times the sine of 180 degrees over n. So this is just a simple explanation or simple way of writing it. Now if we wanted a better and better approximation of pi, we would need to increase the number of triangles, and if we increase the number of triangles, that the angle would get reduced by that number. So if we were to take n as 36 and n as 36, so n equals 36, so we would get the angle, or we would get the theta equals 360 divided by 36, and that would be equal to 10. So if we were to take more number of n, we would get a better approximation of pi, and that would give us the circumference of the circle. So if we were to write it in a better way, more efficient way, or in a way that that others would understand, we would take it as limit. If you don't know limit, you could use the simple way of writing it. And if you were to explain it to someone, you could just tell them that n we can take n as infinity. So limit as n tends towards infinity of this value, n times sine of 180 degree over n, we get the value of pi. So you could do it for yourself, but be sure to take the number as great as possible. So like 10 power is to 6 multiplied by the sine 180 over 180 over 10 power is to 6. And be sure that you don't make any mistakes if in taking the number of triangles or n. So like writing n over here as 10 power is to 6 and writing n over here as 10 power is to 7. And as the number of sides would increase, we would get a better approximation of pi, and that is 3.14159265358 okay. So that's all I know about pi. I mean the digits of the pi. So that's how you derive pi, and you could do it yourself by using a calculator, of course. And that's it for today. And if you like this video, be sure to hit the like button, share, and subscribe to my channel, the Science Maniac. And be sure to share this video with other students as well who love maths and physics and all that stuff. So thank you for watching again.